This lesson is called Can-Do Calculus, and we are looking at infinite geometric series. The learning target you are trying to master is finding the sum of infinite geometric series and being able to tell if it does in fact have one. All right, so if you look at this sequence given here, and we were to find the sum of the first 5, the first 10, and the first 20 terms, you'll notice something happening to this number. The sum of the first 5 terms is 124, the sum of the first 10 terms is 127.875, and the sum of the first 20 is 127.9998779, blah, blah, blah. So if you were to kind of look at the pattern of these three sums, think about these two questions. What's going on with these sequences as we add more and more terms? And what do you think S sub 100 and S sub 1000 are? So if you look at this, it looks like S sub 20, and then if we did more and more, it looks like it might be getting closer and closer to 128. So this is an example of something we would call an infinite geometric series. And what this means is a series is where you add terms together. We've done sequences. Series are where you find the sum. So if you continue to add these together, more and more terms together, you end up getting closer and closer to 128. Here's a visual to kind of show you what we're talking about here and what we mean we're converging. So basically, if you were to look at this as a sequence or as a series, our first term would be 1, our second term would be 1/2, third term would be 1/4. We keep cutting everything in half as we go, right? So basically, as you look at these squares, you start with 1, you go to 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1/128. Then where would you go? 1 2/56, and you just keep going and going. We never actually get to 0. So what we're looking at is, as we add these together, if this were to be a series and we were adding these together, we would end up getting closer and closer to a single number. So here is what we mean by sum of an infinite geometric series. How we find that is using this formula right here. The sum of infinite number of terms is u sub 1 over 1 minus r. And in this case, or in these cases, u sub 1 is your first term. And r is your common ratio. So these have to be geometric series. We have to be finding the sum of a geometric sequence. The catch here is that the absolute value of your common ratio has to be less than 1. All right, so the absolute value of your common ratio has to be less than 1. If it's not less than 1, it does something called diverges. So you're just going to continue to add larger and larger and larger and larger numbers together, or if it's negative, smaller and smaller and smaller, and it's just going to keep adding up to be bigger and bigger and bigger numbers. So your absolute value of r, your common ratio, has to be less than 1. So the sequence must be getting smaller and smaller. All right, so let's look at our first example here. So find the sum of the infinite geometric series if it exists. So first we have to find our common ratio and determine if it exists. If it's going to be converging, we call it. So let's take a look at this. So let's look at this series. We go 1, 1/5, 1/25, 1, 1/25. So your common ratio, or what you're multiplying by every time, is 1/5. All right, so then we have to check and see, is the absolute value of 1/5 less than 1? Yes, it is. So we then say that this converges. Since we're adding smaller and smaller terms together, it's converging, getting closer to one single number as we add more and more together. Since it converges, let's then find what number that converges onto. So in order to do that, we need to use the formula. The sum of infinite terms of this geometric sequence is going to be the first term divided by 1 minus the common ratio. Our first term is 1, so it's going to be 1 over 1 minus r, which is 1/5. Now, you can use your calculator to simplify that. I'm just going to do it by hand. 1 over 1 minus 1/5 is going to be 4/5. Dividing by a fraction is like multiplying by the reciprocal, so it's going to end up being 5/4. Or if you do it on your calculator, you'll probably get a decimal 1.25. All right, so let's try this next one. B, 2 plus 6 plus 18 plus 54. If it exists, remember we have to find our common ratio. It looks like we're multiplying by 3, so our common ratio is 3. And if you look at that, absolute value of 3, is the absolute value of 3 less than 1? No, it's not. Absolute value of 3 is greater than 1. So this does something we call diverges. So since we're adding bigger and bigger and bigger numbers together, we're just going to, as we add more and more, we're just going to keep basically getting to infinity, as many big numbers as we can. Okay? All right, let's go on to the next one. C. -8, 2, -1/2. I know negative numbers can be scary, but let's keep going here. First, we find our ratio, figure out if it exists. Let's see here. So 2 is 1/4 of 8, but it would be the opposite, so we'd be multiplying by -1/4. So it looks like our common ratio is -1/4. Now remember, to test if the sum of an infinite geometric series exists, we take the absolute value of r. So absolute value of -1/4, is that less than 1? So the absolute value of -1/4 is +1/4. Yes, 1/4 is in fact less than 1. So now we're going to take our common ratio and your first term, and we are going to use the formula for an infinite geometric series. So the sum of an infinite number of terms of that sequence is going to be the first term divided by 1 minus the common ratio. Your first term is -8. Your common ratio is -1/4. Now when you put the r in, you don't put the absolute value of r in, you put the actual r value. So we're going to put -1/4 in for r. So this is going to be minus -1/4. So we have -8. Again, you can use your calculator. I'm just going to do this by hand. Minus a negative is like adding a positive. So 1 plus 1/4 is going to be 5/4. And I believe when we multiply that out, multiply by the reciprocal, you would get -32/5. Or if you do that on your calculator, -6.4. So that is converging. This series is converging to -6.4. So far, we have looked at series notation. We're going to look at interpreting these with summation notation. So I'm going to actually start with B, and the reason I'm starting with example B is because it looks a little different. As you can see here, our sum is going from the first term, u sub 1, to infinity. So we're adding infinite number of terms together. That's how we know it's an infinite series. And how we know it's going to be geometric is because it has this power of n. Okay, so that's how we know it's going to be an infinite geometric series. Now we just need to identify what is the common ratio and what is our first term. And then identify if we can in fact find that this converges. So 3 over 2 to the n. First, what we're going to do is rewrite this. So if we look here, this can be rewritten as the sum from the first term to infinite number of terms. And I'm going to rewrite this as 3 times 1 over 2 to the power of n. Now, the interesting thing about this is, if I rewrite this 3 times, I can actually rewrite this 1 over 2 to the n as 1/2 all to the power of n. Because this numerator of 1, if you raise that to any power, it's always going to be 1. And then you also have to use power properties, so then your bottom 2 would have to be 2 to the n. So if you see something like this with the power on the bottom, take that numerator, pull it out as kind of a multiple, and then if you have 1 on top, you can just write that whole fraction to the power of n. So now with this notation, we should see then whatever is being raised to the power of n, so this 1/2, that's going to be your common ratio, if you remember summation notation for geometric sequences. And then to find the first term, you just have to substitute 1 in for n. So we know our common ratio is 1/2. So first let's figure out, okay, so that 1/2, is that going to be converging? Is the absolute value of 1/2 less than 1? Yes, it is. So this will be converging. And then u sub 1 is going to be 3 times 1/2 to the power of 1. So you would get 3/2. So since it's converging and we found u sub 1, let's use our formula. U sub 1 over 1 minus r. So 3/2 over 1 minus 1/2. And then if you do that by hand or put it into your calculator, you should end up getting 3. All right, so I want you to see if you can look at these sigma notations, these summation notations, and see if you can identify in each of these your common ratio. Once you do that, is it converging or diverging? And then if it is converging, what your first term is. So pause here for a minute and see if you can do that. All right, so hopefully you didn't do too much work in letter A, because once you identified r, that's going to be greater than 1. The absolute value of that is greater than 1, so it's diverging. So you can stop there. And then in part C here, the absolute value of -2/3, that is less than 1. 2/3 is less than 1. So then you plug that into your infinite geometric series formula, and you should get 21/5 or 4.2, depending on if you did it by hand or did it in your calculator. And that should sum up geometric series.